Okay, so we're going to do the law of cosines today, right? And just like the law of sines, there's 3 separate formulas you can use, right? Now, I'm just going to cover up 2 of those formulas, and we're going to talk about this one formula here. Now, if you want to know how this formula is derived, you can watch this video right here. And it's basically used about on the same triangle I used before, right? Drawing an altitude, breaking up 2 smaller triangles, and actually using the Pythagorean theorem on the left side and the right side of the 2 smaller triangles. And so the law of cosines is basically derived from the Pythagorean theorem. And it would take me a while to derive it for you, so you can watch this video if you're interested. If not, just look at the formula. You're going to have to memorize it. Since you're home, you can always have it with you, so you don't have to memorize it. But you know, if we were in class, I'd make you memorize this formula. And, you know, just notice, look, if I cover up this part, there's the Pythagorean theorem, right? It's a squared. It's really supposed to be a squared plus b squared equals c squared. In the other, right, look, in the bottom one, I actually have c squared equals a squared plus b squared. But it's just a mixture of the combinations of which sides you have, right? Remember, lowercase letters, a, b, c, those are the sides, right? That's what you use Pythagorean theorem for. And if you notice, it's just minus 2 times B and C are the 2 sides you're going to use, and you're going to do the cosine of A. Whatever side you're trying to find that you're going to equal the formula to, like A squared, you're basically going to have to do the cosine of whatever that angle is, because angle A and side A are opposite each other. And this formula just varies. You know, if we're trying to find side B, well, I'm going to do the cosine of B, and then look, A and C are in the formula. A and C are in the formula. That's it. It's just it just plays around with, right, the different sides that you have. If you're trying to find C, side C, right, okay, you're going to do the cosine of angle C, but then look, A and B are in the formula. So basically, that's really it. And you can use this when you want to find missing sides, and we can also do missing angles. Now, I'm going to write something on the top of the paper that I didn't really, well, we kind of were doing it, but I never really mentioned it before. When you use the law of sines, right? When you use the law of sines, you're basically, you know, using a side, angle, side relationship, right? Or you're using an angle, let's see, you're using an angle, angle, side relationship. Or I was going to use ASS. I don't want to use that. I'm going to do side, side, angle. This one does not work. Remember that. But you're using the law of sines whenever you have these missing or these pieces given to you and you want to find the third piece. It's interesting. When you use the law of cosines, right, the relationship of the triangle is always a side, angle, side relationship or a side, side, side relationship. And if you remember back to the lesson yesterday, right, whenever we had 3 sides, we couldn't use the law of sines because we needed an angle in there, right? Okay? And it's the same thing, you know, when we had, well, you could probably find an angle if you had this, but normally, like, you know, you need these 2, if you have these 2 combinations in your triangle, you're always going to use the law of cosines. If you have these combinations, you're always using the law of sines. So just to relate that back to, you know, congruent triangles, it's an interesting fact that that happens. Now, I'm just going to actually show you how to plug in the formula and use it, all right? And if you want to watch and see how it's derived, you can watch this video. It'll actually tell you how the formula is made, but that's going to take me some time. And you know me, I'm trying to keep my videos short. All right, let's do number 1. Solve for all the missing requirements. Okay, I got 12 centimeters, 25 centimeters, and I've got B here, right? Okay. Now, I cannot use Pythagorean theorem on this triangle because it's not a right triangle. You know what I mean? If it was a right triangle, I'd use Pythagorean theorem and be done in 2 seconds. But I can't because this is, remember, an oblique triangle. So, I'm basically, you know, I come over here and I've got one side over here. I'm going to call this side C. I got one side 25 over here. I'm going to call that side A. There's angle B, and I'm missing B. And you can't use the law of sines on this because I would need to set up a ratio. And I don't have enough information. I need an angle over here or here to give me the ratio of sine A over A, and then I could do sine B over B and figure it out. But I don't have that. So basically, I've got 2 sides with an angle in between. This is side, angle, side. I can't use law of sines, and I can't use Pythagorean theorem, and I can't even use basic trig because it's not a right triangle. So I'm going to use the law of cosines to help me, right? And again, I'm trying to find B. All I'm going to do is I'm trying to find B. I'm going to say it's B squared equals Now notice the formula up here. It says do a squared plus c squared. Okay, you have the numbers here. It's 25 squared, right, plus 12 squared, right? And then it's minus 2. And look, it's minus 2 times AC. You just multiply them again. So we'll do times 25 times 12, right? And then, you know what? We're going to multiply it times the cosine of the angle, and the angle is B. So we're going to do 80 degrees. And remember, you're doing the cosine of angle B, and we're trying to find the opposite side B. That's when you actually need to use this formula. And so you'll see, you know, I'm going to be honest, this formula is, it's easy, but it's a pain to set up, right? So now I just got to go through and crunch all these numbers. So guys, I'm going to be completely honest with you. I'm going to take my calculator. Here's for some of you guys. I'm going to make sure the mode is right. Whoops. I'm going to make sure the mode is right. I'm in degree mode. Good. I'm just going to pop all this in the calculator, and I'm going to do it, right? 25 squared plus 12 squared, okay? Minus 2 times 25 times 12 times the cosine of 80 degrees. And basically, it's giving me, right? It's giving me 664. I'm going to say 811, right? 09. I'm going to write 4 decimal places out, and it says B squared, okay? All right? Did I solve for B yet, though? Absolutely not. What do you have to do to solve for B? Square root, square root. It's like the Pythagorean theorem. B equals whatever the square root of that is. Now, you guys can't simplify that. I'm going to do second square, and I'm going to type in 664.81108, okay? And it's telling me that the side is about 25.78. And here's the problem with the quiz. It's centimeters, right? Okay. And that side looks like it's about 25.78 centimeters. Okay, that's reasonable. I mean, think about your answer. If you're getting 150, one side's 12 centimeters, one side's 25. You remember, you got to add 2 of the sides. It's got to be greater than the third in order for it to be a triangle. So that's reasonable. It's a little bigger than that side. It's like 26. Okay. I mean, that's the answer. And all I did was I used, right, the law of cosines formula, and I plugged in whatever I had. So, you know what? Yeah, I'm basically going to go and do the same thing. Now, watch number 2 with me, right? There's a bunch of information here. They give me angle B, they give me side A and side C, and they said solve for the triangle. Okay. I'm going to come over here, and I'm basically going to draw the triangle, right? I'm just going to draw it A, B, C, right? Okay, and they're telling me angle B is 34 degrees. They're telling me A, which is over here, that's 8 centimeters. C is over here, B is over here, C is 12 centimeters. All right, just so you have a little diagram as a reference. And they want me to go through and find all this information here. Okay. If you notice, this is a side angle side relationship. I could use the law of cosines to find side B. And that's exactly what I'm going to do. If I see the side angle side relationship with the 3 pieces of information, I'm going to do that. I can't use the law of sines, guys. I don't have enough information. This is not the ratio. I need B in order to do law of sines. So you know what? I'm going to do law of cosines. We're going to do B again. So we're going to do B squared, right? And just remember what the formula is. It's A squared plus C squared minus 2 times A times C, right? Times the cosine of whatever the angle is 34, okay? And basically, and you know in the calculator, it's going to make you put that in parentheses. So that's it. That's all I got to do. Once you know the formula and you guys have it set it up here, label your diagram to help you. And you know what? You need to go through and put this all in the calculator. So it's pretty easy. 8 squared plus 12 squared, right? Times 2 times 8 times 12 times the cosine of 34. Okay? So, oh my Lord, that is a huge number. Well, you know what? I got to do the square root of that number. And so, yeah, basically, I believe that that's going to end up being what it is, right? Although I have a feeling I made some type of mistake here. Yeah, I know what my mistake is, so I'm going to redo it. Lord help me. I got to do minus, right? And then I got to do times 2 times 8 times 12, right? And don't do times. Delete that. It's minus 2 times 8 times 12 times the cosine of 34. typed it in completely wrong. That's it. It's 48.8247. And you know what? Don't forget to take the square root at the end, okay? There's a point there. Take the square root, do seconds squared, 48.8247. You know what? Type in a couple of decimal places, and it's giving me 6. All right, I'm just going to round it to 2 decimal places. I get 699 centimeters, all right? And there's B. B is 6.99, all right? That's it. So I got that. Now I got to figure out angle A and angle B, okay? All right, watch what I'm going to do. I'm now going to use the law of sines, okay? And here's a trick. You need to do this, right? Okay? Find the smaller angle first. Okay? This is important. You got to find the small angle first, the smallest angle first, right? Okay? All right. How do I know what angle is the smallest angle? I got 6.99 here. So here's the trick. You guys remember this? 6.99 is B, A is 8, C is 12. So the smallest angle is actually 34. I already know that because 6.99, right, okay, is the smallest side. That should be the smallest angle. Go find the next smallest angle. You see 8 is A. The next smallest angle is A. It goes in order. The bigger the side, across from it's going to be the bigger angle. That comes into play now too. We did that so long ago. So my goal now is to find angle A. And watch what I'm going to do. I'm going to do law of sines. I'm going to do the sine of angle B, which is 34, over the side that I found, okay, which is 699. And now I'm going to set up. I'm going to do the smallest angle. I'm going to do sine of A, and I'm going to do it over 8. Very, very, very interesting that I actually have to go through and do that now. You guys know what to do. We're going to cross multiply this guy, right? Okay, watch what's going to happen. 6.99, right, times the sine of A. I'm just going to put that in parentheses, right? This is going to be 8 times the sine of 34, right? Not messing around with decimals. So then I got to divide this out, guys. You see that? Got to divide 699 out, okay? And that'll give me the sine of A equals, I don't know what this is. Need to do it on my calculator. And so I'm going to get my calculator here. 8 times the sine of 34. I got that. And then I'm going to divide that by 6.99, right? And I didn't divide it right because I'm having trouble with my calculator, okay? It's that, and I'll divide it by 6.99, okay? I get 0.6399. All right, I'm just going to do 0.6399, okay? What do I do next? I don't really have, right? I don't really have an angle, but do you guys remember what to do here? If I'm trying to find the angle that's next to sine and I have a decimal, I'm going to do the inverse, right? Okay, I'm going to do the inverse here. So remember what the inverse is? In your calculator, it's the sine of -1, and I'm going to do 0.6399. That's all I'm going to do. I'm going to type that in the calculator. The inverse of 0.6399, okay? And look, it's about 39 point. Okay, I'm going to round this to the nearest degree. It's not telling me whatever IXL tells you to round to. I'm going to round it to 40 degrees. So angle A is 40 degrees. So look at how I actually set this up. I used the law of sines. I went to cross multiply. I ended up with sine of A. If you're trying to find an angle, divide everything out, multiply whatever you need to do. And when you're done, once you get your decimal, that looks like all the decimals we've seen so far, do the inverse, right? So I got to do the inverse, and there it is, angle 40. Okay, whoops, that's angle A. Angle A is 40, not angle C. Once you figure out that angle, right, you have the 2 smaller angles. How big is the third angle? 40 plus 34 is that. Okay, 180 minus 74, you know, this one's 106. All right. That's a lot of work. Listen. This is like, really, this is like Algebra 2 work here. You know what I mean? Teaching you just the basis of the formula, that's great. I did it on this side. This is more practice with the law of sines. And I wanted you to see if you had to find an angle, you got to remember the inverse, right? Okay. All right. The homework sheet's got questions like this, actually, right? Always find the smaller angle. I'm going to do this last problem, and then I'm going to write down 2 notes for you, okay? I better read this one correctly this time. All right. But they want to know what the width of the river is to the nearest foot. I'm going to say that it's this one. Doesn't this look like the width of the river? Yeah, the other 2 don't. But basically, it's about a rock climber climbing. He's at A, and he's looking down. He's about 125 feet from one point of the river. That's one side of the river. It's 125 and 200 from the other side. And look, he's got an angle right in there. This, I can't use the law of sines. I'm going to have to use, right? I'm going to call this A, call this B, call this C. I'm going to have to use the law of cosines, right? Okay, that's easy. And do it down. Well, I guess I'll do it over here on the side. So we're going to do A squared, and then we need B and C. That's this, 125 squared, 200 squared, minus 2. I wasn't doing that right in the calculator. Minus 2 times, all right, 125 and 200. And then you're going to do times the cosine of 25. And that'll have to go in the calculator like that. And that's really it. I just plug the information in. Plug the 2 sides squared here for Pythagorean theorem. Multiply 2 times those 2 sides, right? Okay. The 2 really means because you have 2 triangles on, you know, inside of that original triangle. And I got to do the cosine of that angle. All right. That's it. I'm just going to go ahead and plug all the numbers. I'm going to plug away. Hopefully I can type this in right. Okay. Minus 2 times 125 times 200 and times the cosine of 25. Okay. All right. So it's giving me that. All right. It's giving me A squared is 10,309. And it's 0.6106. I'm just going to write the whole thing in. But I got to do the square root of that. All right. So let's do the square root of this. Right. And see what we end up with. Okay. All right. So there you go. It looks like it's 101. So you know what? It says to the nearest foot. Look, I don't always read, but I'm going to round it when I take the square root. Okay. This is going to end up being about 102 feet. That's how far apart the river is. And listen, that makes sense. Look at your diagram. 125 feet, 200 feet in the triangle. Yeah, that's 102 feet. That works out pretty close. So, you know, just go through and you're going to do these. And I'm going to write one other note on here. When you're trying to find the angle with the law of sines, find the smaller angle first, okay? All right? If you're going to find angles with the law, right? And hold on. If you're going to find angles with the law of cosines, right? Okay? And this is all angles, right? So just remember, you're going to have to use the inverse. But here's a little trick. When you use the law of cosines, find the smallest angle first. When you do the law of cosines, it's the opposite. You find the bigger angle first. And that's just a little rule. So you're going to see that maybe on the homework, you know, you'll see that when you have to find an angle using the law of cosines, find the bigger angle first, and you should be able to figure that out. But try it on the homework. There's a couple problems I'm giving you, and there's also IXL homework. All right? Good luck.